This is the worked answer to the Unit 7 test, question 4. So we have a particle P that passes through the point A at 2.8 meters per second, constant acceleration of 0.12 meters per second 3 seconds later, a second particle Q passes through A with a velocity of 2.4 meters per second, but a constant acceleration of 0.2 meters per second. So it's travelling slower, but it's accelerating faster, and it leaves afterwards. Write down an expression for the displacements of both of them, and then find where they meet. So, what I'm going to do to try and explain this is I'm going to kind of have a table of values. So I'm going to say that when t equals 0, 1, 2, 3, 4, 5, and so on, and that will go on forever. For particle P, it's travelling at 0, 1, 2, 3. It's travelling at all these times. For particle Q, it only travels from here, so it's starting afterwards. So I'm thinking about this is relative to when the first particle passes. So what we can think about, if this is 0, 1, 2, 3, 4, 5, this would be 0, 1, 2. So the time for Q, we have to take away 3 to get the time for P. That idea is going to be really helpful in a moment. So displacement, S equals ut plus a half at squared. So I'm going to do it for P. So for P, I'm getting S equals 2.8t plus a half of 0.12, so 0.06 t squared. I'm going to do the same for Q. So S equals the starting velocity of 2.4, but this time t is different. This t is not the same for Q. This t we have to take away 3 to get there. So it's t minus 3 plus a half of 0.2, so 0.1, and again the t is not the same as this t, we had to take away 3 to get it relative for Q. So this is the answer to A. This is the displacement for P, and this is the displacement for Q, given that we're using time when the first particle went past. In part B, they want you to find where they meet and show that this can be expressed as a certain quadratic. So in other words, they will meet when you solve this simultaneous equation. So 2.8t plus 0.06 t squared is equal to 2.4 t minus 3 plus 0.1 t minus 3 squared. And I could expand that and show you that it gives the quadratic, and it does. So I'm just going to take that as given that you can do that. So 0 equals 2t squared minus 50t minus 315. One thing that did come through when I was doing this question is at one stage you get 0.04 t squared minus t minus 6.3. Use this 50 as a clue what you're multiplying it by. So to get rid of all the decimals, multiply it by 50 and it works a lot nicer. In part C, we're asked to find the distance from A when they meet. So what we're going to do is we're going to use the quadratic formula. So hopefully you have a calculator that has the formula solved on it. And we have a polynomial equation, and it's degree 2, the biggest power is 2. So A is 2, B is minus 50, C is minus 315. And that gives me 2 times T1 equals 30.21. T2 equals minus 5.21. So this is the time when the two particles will meet. So it can't be that, because they can't meet before they went past A. So we can't get negative time. So this is the time I'm going to be using. I wasn't asked for the time, I was asked for the displacement. So I need to substitute this into here or here to get the actual displacement. They're at the same place, so whichever you substitute in will work. I'm going to substitute into this one because it's a slightly easier process. So I'm going to go back to calculator. One thing I'm going to do that's quite clever is I'm just going to type in 30.21 and press equals. This is now stored as the answer. So when I do 2.8 answer plus 0.06 answer squared, I get 139 is the displacement. That's the question done.